Yeah, vanakkam pa. Good morning, vanakkam. Vanakkam. Yeah, check here. Okay, vanakkam pa. Welcome. Am I audible pa? Vivekananda. Vivekananda from Koilpatti. Chetana pa? Fine pa. Thank you, Vivekananda. Okay. I will also bring my attendance. Wait a moment. Okay, pa. Sorry for late. Huh? 5 minutes just yet. Even you people also late to join the class. Okay, because of my startup, myself starting late. Okay, I have to admit that. Let me take attendance. Let me check whether people are available. Okay, I'm today I'm available from another room. This is my study. This is my study room. Today my okay. Till yesterday there was a different setup. No? Okay. Attendance. Okay, Aditya RS.
Sir, present, sir.
Welcome, pa. Aditya, yes. Okay, Abhishek. Achyutan.
Present, sir.
Welcome. Aishwarya, yes, 2002.
Present, sir.
Welcome. Aishwarya, yes, 23.
Present, sir.
Aishwarya, that means Aishwarya Saravanan. Yeah. Correct, Namo?
Yes,
Aishwarya
sir.
2003 Saravanan.
Yes,
Fine.
sir.
Ambika.
Present, sir.
Ambika from what is it? Tiruvannamalai Mangalam. Correct, Nama?
Yes, sir.
Nice, ma. Happy to listen to your audio. Okay, welcome. You are the only Tamil medium student, I suppose.
Yes, sir.
Bye, Brian. I'm Tamil medium. I had a company. Thanks.
Thank you, sir.
Thank you. Amrita Varsini.
Present, sir.
Amrita Varsini from Telugu. Okay, background. Fine. Amrita Varsini, what is it? Amjigari, amma? Amjigari.
Yes, sir. Yes.
Right. Amjigari engama kanta? Chennai Nagara?
Illa, sir. Nelson Manikam Road.
Nelson Manikam Road. That is opposite to. Right. I could understand. No problem. Aravindan.
The present, sir.
Welcome. Ashwin Kumar. Ashwin Kumar B. Varlepa. Dharmesh Kumar. Dharmesh Kumar available. Okay. Welcome, Pa. Dravya Devi.
Present, sir.
Welcome. Gautam, yes.
Present, sir.
Okay. Geeta.
Present, sir.
Geeta from Devikapuram. Correct, Rama?
Yes, sir.
I heard that you do a lot of social service. அப்படியா?
Sir.
Great,
Right,
great.
sir.
பரவாயில்ல, பெரிய விஷயம். Great thing, ma. I'll ask questions related to that. Okay, classல பார்க்கலாம். Then Geoffrey.
Present, sir.
Welcome, pa. Moktika.
Present, sir.
Harish.
Present, sir.
Welcome. Harsha Anand.
Present, sir.
Welcome. Hemant Ram.
Present, sir.
Okay. Jalasri.
Present, sir.
Welcome. Firstly இருந்தீங்க. Janarth.
Present, sir.
Jayasri.
Present, sir.
Welcome, ma. Madhav.
Present, sir.
Meenakshi Sundaram.
Present, sir.
Meenakshi Sundaram. Okay. Okay. Michael Samuel.
Present, sir.
Mogan classல பார்க்கல இன்னும். Nitish Noel. Nitish வந்துட்டீங்களாப்பா? Okay. Chaitanya.
Present, sir.
Okay, welcome. Purnima.
Present, sir.
Priyavadana.
Present, sir.
Okay, welcome. Ragul.
Yes, sir.
Welcome. Sandhya.
Present, sir.
Okay. Santosh GDP.
Yes, sir.
Santosh from Kallakurichiappa. Where are you from?
Native Kallakurichi, sir.
கள்ளக்குறிச்சியில எங்கப்பா?
அது விருகாவூர்னு ஒரு இடம் சார். டவுன்.
நைஸ். நியர்பை இங்கெல்லாம் போயிருக்கீங்களா? கல்வராயன் ஹில்ஸ் எல்லாம் போயிருக்கீங்களா?
போயிருக்கேன் சார்.
ஈவன் அங்கெல்லாம் நான் போகணும்னு பிளான் பண்ணிட்டு இருக்கேன். போகணும் பார்க்கலாம். நைஸ் பா. தேங்க்ஸ். ஹாப்பி டு நோ அபௌட் யூ. சரத்குமார்.
Present, sir.
வெல்கம். அக்ஷதா.
Present, sir.
ஓகே. சிவசண்முகம்.
Present, sir.
சிவசண்முகம் எந்த ஊருப்பா? கன்னியாகுமரி. யாரோ பூந்தமல்லியில இருந்து யாரோ ஒரு பையன் இருக்காங்களாப்பா? யாருது? பூந்தமல்லி. ஓகே, மறந்துட்டேன், பேர் மறந்துட்டேன். சிவசண்முகம் கன்னியாகுமரி எங்கப்பா?
அழகிய பாண்டியபுரம்.
அழகிய பாண்டியபுரம். ரோஜா பார்த்துட்டீங்களா? இன்னும் பார்க்கல இல்ல? சரி, நான் கேட்கலாம். பார்த்தீங்களா இல்லையா ரோஜா? சும்மா ஒரு ஸ்டார்டிங் சீன் பாருங்க. இப்போ
இல்ல சார்.
உங்க அப்பா அம்மா கேட்டா சொல்லுவாங்களே ரோஜா பத்தி. சரி, ரைட். ஸ்ரீராம். வெல்கம். சிவசுப்ரமணியன்.
Present, sir. Sir, நானா சார் அது பூந்தமல்லி. நேட்டிவ் வந்து கோவில்பட்டி சார். பூந்தமல்லி சார்.
கோவில்பட்டில எங்கப்பா?
கோவில்பட்டியில வந்து வண்டானம் சார்.
எவ்வளவு தூரம் அது தெரியல எனக்கு.
அது வந்து இது கடம்பூர் பக்கத்துல சார்.
கடம்பூர். நம்ம கடம்பூர் பெரியாள் இருக்காரு.
வாவுசி இருக்காங்க சார். அதே ஊர் தான் சார்.
ஓட்டப்படாரம்பா அது?
இல்ல, தெற்கு வண்டானம் சொல்லுவாங்க சார் ஆக்சுவலா.
கடம்பூர் தாண்டி ஓட்டப்படாரம்.
அதான் அது பக்கத்துல தான் இருக்கு சார். எக்ஸாக்ட்டா தெரியல.
சரி, சூப்பர்ப்பா. நல்ல ஊர். எங்க ஊரெல்லாம் பக்கத்துல. அங்க இருந்து 30 கிலோமீட்டர் ரேடியஸ்ல 30 இல்ல 40-50 கிலோமீட்டர் வரும். ஓகே,
தெரியும்.
ரைட்ப்பா. சந்தோஷம். சோனிகா.
Present, sir.
கோல்டன். ஸ்ரீ வர்ஷினி.
Present, sir.
வர்ஷினி யூஸ் டு டிராவல் a lot. கரெக்ட் தானமா?
ஆமா சார்.
எங்க சுத்திருக்கீங்க? நிறைய. ஈவன் செட் அபவுட் மூணாறு, வேற என்ன வயநாடு நிறைய சுத்திருக்கீங்க. ஹவ் அபவுட் நார்த் இந்தியா?
சுத்தி இருக்கேன் சார்.
நிறைய. பரவாயில்லையே. எனக்கும் ஐ am also having similar interest. That's why அட்லீஸ்ட் ஒரு 2-3 மாசத்துக்கு ஒரே ஒரு டிக்கெட் போடணும். நான் எனக்கு என்னோட ஐடியா வந்து ஒரு 3 மாசத்துக்கு ஒரு டிக்கெட் போயிட்டு வெளியே எங்க போயிட்டு தான் ஒரு ரிலீஃப். கிரேட். இன் தட் வே ஜனவரி பொங்கலுக்கு நான் உங்க வத்தல்மலை வந்தேன். அதுக்கப்புறம் பிப்ரவரி மார்ச் ஏற்காடு ஃப்ரம் ஏற்காடு டு பொம்படி. அண்ட் அகைன் இன் ஏப்ரல் ஐ மேட் பொம்படி டு ஏற்காடு. ஒரு 3 மாசத்துல 4 மாசத்துல 3 ட்ரிப் போட்டாச்சு. குட்.
ஆமா சார்.
எல்லாம் உங்களை மாதிரி தான். ரைட். இல்லைங்க, வேற எங்க போயிட்டா? அவங்க ஸ்ரீவாசனை முடிச்சாச்சு. குட். ஸ்வாதி கிருஷ்ணா. ஸ்வாதி. டான்சர், கிளாசிக்கல் டான்சர்.
Yes, sir.
Dancer and advocate, no? Correct.
எஸ் சார்.
இன்னைக்கு நானும் உங்க மாதிரி ஒரு கெட்டப்ல வந்திருக்கிறேன் இன்னைக்கு இல்லையா? மை பேக்ரவுண்ட் திஸ் இஸ் மை ஸ்டடி ரூம். ஸ்டில் சரியான பேக்ரவுண்ட் இல்ல, சரியான டைரக்ஷன்ல இல்ல. ஓகே. ஸ்வேதா
Present, sir.
வெல்கம். தருண்குமார் வரலையா? திவ்யா
Present, sir.
வெல்கம். உமையா
Present, sir.
உமையா ஃப்ரம் செட்டிநாடு காரைக்குடி. கரெக்டாமா?
Yes, sir.
Great. Happy to know about you. Vaidish. Vaishnavi.
Yes, sir.
Vaishnavi எங்கம்மா மறந்துட்டேன்.
Sir, Porur, sir.
ஓ போரூர். கிரேட். போரூர்ல எங்க படிச்சீங்க?
Omega International School, sir.
ஓ தெரியல எனக்கு எங்கன்னு. ரைட். போரூர்ல எங்க?
போரூர்ல முகலிவாக்கம்.
போரூர் இந்த S&S சொல்லுவாங்க முன்னால இல்லையா? S&S WS that companies were available. Now it's not available. முகலிவாக்கமா மௌலிவாக்கமா?
முகலிவாக்கம்.
அந்த S&S கேள்விப்பட்டீங்களா? S&Sங்கிறது ஆக்சுவலி ஒரு சுவிட்ச் கேர் கம்பெனி. இப்போ அது கம்பெனிலாம் எல்லாம் மூடிட்டாங்க.
இல்ல சார், நான் கேள்விப்படல.
கேள்விப்படல. ஓகே சாரி. எங்களுக்கு அதான் ஒரு லேண்ட்மார்க் அது முன்னால. ரைட். யாரு பேசனா? வைஷ்ணவி. நெக்ஸ்ட் வர்ஷா.
Present, sir.
வர்ஷா ஓகே வர்ஷா ஒரு வருஷா தான். ரைட். வர்ஷினி தான் ரெண்டு பேருங்களோ? ஸ்ரீ வர்ஷினி அண்ட் வர்ஷினி. வர்ஷினி.
Present, sir.
வெல்கம். வருண்.
Present, sir.
வெல்கம். வருண் ஃப்ரம் நம்ம மந்தவழி இல்லையா? மந்தவழி மயிலாப்பூர் ரீஜன். ஓகே. விவேகானந்தா. விவேகானந்தர் அம்மாலே பார்த்தனே
சார் சாட்ல போட்டுருக்கேன்.
சரிப்பா. ரைட். எந்த ஊர் பானீங்க? விவேகானந்தா மறந்துட்டேன். ஓகே. மேபி ஆடியோ கிளாரிட்டி இருக்காது. வித்யா.
Present, sir.
வெல்கம். ஈவன் நீவங்கிட்ட ஒரு நிமிஷம். ஜெயஸ்ரீ நினைக்கிறேன். சப்போஸ் சி செட் அபவுட் சி யூஸ் டு மெடிடேட். யாருமா மெடிடேட்லாம் பண்றது கிளாஸ்ல? கிளாஸ்ல இல்ல, சி யூஸ் டு டூ மெடிடேஷன் ரெகுலர்லி. ஜெயஸ்ரீ தானமா? கிரேட்மா. That is, you said like you are going to do it regularly. Even I also started this practice. Today is the 4th day. Not actually very meditation. It is kind of like the yoga and related. What is called the Sudarshan Kriyana art of living la or exercise they used to give some 30-35 minutes that I am doing since the start of the class. 10th மேல இருந்து பண்ணிட்டு இருக்கேன். Okay, happy to know about you, and I will also try this activity at least till the end of this semester. Vignesh, yes.
Present, sir.
Welcome. And Guru.
Present, sir.
Welcome. Yukesh.
Present, sir.
Okay. I think the audio submission deadline முடிஞ்சிருச்சுன்னு நினைக்கிறேன். I will extend that. Maybe நாளைக்கு அது
Roll number 10, Ashwin. Present.
அஸ்வின் ஒரு நிமிஷம் பா.
Sir, Aditya, yes.
Okay, Ashwin, Aditya, yes. Abhishek TM, I will call again. Abhishek TM.
Present, sir.
Come. Then Mohan, Nitish, Antara, Vaidish, Tarun Kumar. If any of you are available, let me know. Okay, class கொஞ்சம் நிறைய போக வேண்டியிருக்கு நமக்கு. Yesterday we discussed about unit conversions. I even said about an activity what is called as getting to know about ice house. Yeah. I came to know that some of you visited this building what is called as ice house. Why this ice house building is a historical building? Can any of you say this or okay, the Jalasri. Or Harish, சொல்லுங்கப்பா.
Sir, in the British time, I think it was used to store ice.
Okay, good.
Blocks.
Yeah, right, correct. Even Arvind is also trying that. Right, why they store the ice and what is the usage of ice? Of course, usage of ice people can easily say that. Preserve something. Okay, yeah, that is also that is refrigeration is to even we used to keep our contents safely in the refrigerator or even what is it the room la pandranga illaya, like cold storage, right? ரீசெண்டா கோல்ட் ஸ்டோரேஜ் ரிலேட்டடா ஒரு படம் வந்துச்சு பாத்தீங்களாப்பா? என்ன படம் அது? I forget that name. ஒரே ஒரு single lady. Okay, I'll let you know about this movie in the next class. Okay, now next to continue the discussion, let me start this file. Take this file from here. So unit conversion quickly to let me open this file and share these contents. Let me put this content into share. Okay, screen sharing to share. Okay, whatever is opened. One minute. Yeah. Fine. Sorry. Okay. Always to give an overview of common unit dimension, understand the digest common unit conversion factors. Always, this unit conversion should not be a problem. That's why always in understandable way I will try to give an idea. So this distance and area. Okay, this related to area. There's one important thing is the recent time people are saying about this square feet. No, cost of the square feet of a land. About in Chennai city, you can see this cost of sort of about 10,000 rupees per square feet is also very common. Even in this Adayar area, it may be still costlier. Maybe in Tambaram region, it will be about some 3,000-4,000 per rupees per square feet. Otherwise, this denominators keep on changing. You know, earlier about 20 years back, we used to say this land cost in terms of so much of lakhs per acre, and that changed to so much of acre per so much of lakhs per cent. Cent is how much. What is the connection between acre and cent, and what is the connection between cent and square feet? So these are all to be known. Then only you can understand about the this cost price increase of cost price with time. About 2-3 lakhs per acre in 25 years back. During 1995 and all, we can purchase this land near the Porur area for a rate of about some 2-3 lakhs per acre. And it went to about in another about 10 years time 2-3 lakhs per not 2-3 lakhs, even 5-6 lakhs per cent, and again increased to now it is after about even 5,000 rupees per square feet. So otherwise these charges are keep on increasing. Can any of you say the reason for this increase of land rate? I'm not saying about it's not about real estate class, but you should know about them because these are all the availability. Land is limited, and even whatever the produces that could grow in a land also limited. So we are going to survive by using this availability. Not only this, these are all the essential items for every human. In addition, over and above, we are producing a lot of chemicals. So these chemicals many times they are for keeping the producers safe, or we are using these chemicals for say preserving, or the chemicals for converting the product feed into some other better product. So in that way, this land, everything is very important to know. You should know the cost of every item. Okay, so I can quickly say this hectare is actually SI unit for area, which is 100 meter by 100 meter. Let me check whether this screen is shared now. Okay, screen sharing. Device la on pannirappa, so that I need not ask for your consent. 1 minute. One minute. I'm logging in from other device so that I can have how the display is going on there. No? Yeah, about to start. Fine. Even yesterday we said about this pressure and temperature are the very most common units, not only in chemical industry. It is also the common unit of measure in even this our medical field as well, or even to check your health. People always doctor used to check your temperature and pressure. So temperature, body temperature is 36.9 degrees Celsius or 98.4 degree Fahrenheit. So using that, you can connect this Fahrenheit and Celsius, which is degree Fahrenheit equal to Celsius multiplied by this 9 by 5, add to that add 32. Otherwise, in terms of Celsius and Fahrenheit rise, it is 1 degree Celsius rise is equal to 9 by 5 degree Fahrenheit rise. And you can, using this formula, you can also check that at minus 40 degrees Celsius, always minus 40 degrees Celsius and minus 40 degree Fahrenheit are also the same. Okay, and this temperature in Kelvin will be used mainly in the thermodynamic studies, because we'll be using this equation of state to connect the variables of importance, which is pressure, volume, and temperature. So in that we'll be using this temperature in Kelvin scale, because the ideal gas equation is based on the Kelvin scale, and whatever the all these thermodynamic variables are based on this Kelvin scale. And related to Kelvin, another absolute temperature thing is Rankine, which is obtained by adding 462 Fahrenheit. Okay, these are all absolute skills, which means there is no negative values for Kelvin or Rankine. Okay, and force. Force is okay. Force, 1 Newton is 1 kg multiplied by 1 meter per second square. There is always 1 m into a. Acceleration is simply 1 meter per second square. Whereas 1 kg force is 1 kg with the acceleration of this acceleration due to gravity. So in that way, 1 kg force and 1 Newton are having this connection. 1 kg force is 9.812 Newton. Okay. And you can also convert this LB force to Newton. One LB force is or what is it 0.454 kg, which is LB mass multiplied by 9.812 for the what is it acceleration due to gravity. Okay. And energy, yeah, related to energy, I can also ask another data. No, okay, already the data is given, but people used to say the energy, food energy they are consuming, which is of the order of about 10 megajoules per day. Otherwise, people used to say like 2000 calorie. Otherwise, what is the energy content of any food item? They say like 100 calorie, 200 calorie. So whatever the figure they are referring is actually kilocalorie. It is not simply calorie. So if you take some what is it one meal, no, in the morning, you will be taking energy of about 800 kilocalorie. And if you make distance of about 30 kilometer of long running, you will consume this 2500 kilocalorie. That's why, this marathon runners, after a distance of about 32 kilometers, they will feel tired, and they need to have a consumption of this intake of any food items. Even I came to know that there are some runners available in your class, no? There is, I came to know about a girl used to run regularly. Yaar mother, who is a regular runner? And many of you are good swimmers, no? I know about your swimming skills. Even many of you people love swimming. Yaar mother, who is running regularly? Of course, any sports person supposed to run. Running and cycling also people are doing. Okay, maybe people are busy. Okay, na best kekudappa. Am I audible? Since there is no.
Yes, sir.
Yes, sir.
Right.
Yes, sir.
You're
Thank you. Okay, how many of you are running? Okay, village people normally used to walk. That is a part of their life. At least even I could run comfortably even at the age of 45, 47. All this because of my this all because of my childhood habits. No, we used to make a distance of about 5 kilometer daily. Is for school up and down of 3 kilometer and another about 2-3 kilometer for going to the agricultural field. So that was part of daily life. After about till my college education, okay, I was having touch with this agriculture. And right from this 2000, what is it? Right after my collage, this from after my age of 22, 25, I don't have this access to my village. Otherwise, my entire village, otherwise my entire family moved to Chennai. Yeah, Geoffrey is running every day. Great, happy to know about you, Geoffrey. Likewise, even I came to know about a girl who is also running regularly. Okay, I can check these contents now. Geoffrey, nice. Better to have many devices parallelly. Okay. Okay, these are all part of life, no? Because of that makeup, is that brought up, I cannot, I don't fear this walking a long distance. At least even I could make a distance of about 85 kilometers in a day. That was the longest distance I covered in a day. Even I am planning to make another such thing in maybe in another about month time or so. Okay, once the lockdown is released, we'll try for that. Okay, coming to the energy now. Energy requirement is about we are consuming a food energy of about 10 megajoules. That is 2500. If you multiply this with 4.2, you'll be getting roughly about 10 megajoules, which is an easy figure to understand. So daily we are taking 10 megajoules. In terms of this energy content of this fuel, this roughly this calorific value of coal, no? Coal is having an energy of about 20-25 megajoules per kg. So otherwise we are consuming energy after about or 1/2 kilo marakari sapra lokana energy we are taking. 0.5 kg of coal we are consuming. In that way you can easily understand. Or if you want to still understand in a better way, this petroleum fuels are having an energy content of about roughly about 40 megajoules per kg. Or even ethanol is also having that much of energy. So in that way, if you say like a person is consuming about 1/4 of oil, that's why people are, we used to see that people ஒரு quarter அடிச்சு குப்புறக்கு படுத்துறான்னு சொல்றாங்க இல்லையா, quarter அடிச்சா என்ன ஆகும், they will be, at least they will be drowsy. Quarter is like, what is it, ethanol, no? Ethanol, 1/4 of oil is having energy as equivalent to that of the energy you are consuming in the form of food per day. So in that way, you won't now forget this energy consumption by a person in a day, which is 10 megajoules is equal to about 1/4 of the petroleum oil. Of course, petroleum oil and ethanol is also having the same kind of energy in terms of kg. That's why even people are also thinking of, or even still using this ethanol as a fuel in automobiles, no? What is it? Bioethanol is normally used in countries like what is it? Brazil. Okay. Always you should whenever you report any data, at least you should be in a position to digest that unit, no, quantity. So whenever you see some unit of say 10 megajoule of energy, so you should easily relate to the energy you are consuming, or energy you are getting from this electricity. So whatever the way you can relate, you can try to understand that way. So the basic unit of energy is calorie, which is actually simply the gram calorie. Whereas people, the food energy they are taking actually kilocalorie. So 1 calorie is equal to 4.184 joule, or sometimes even 4.2 also they say, or 4.187. Okay, nariya confusion la irukku. 4.184 we'll use. Okay, then next to energy is the power unit. Power is energy by time, no, rate of consumption of energy. Typical how to understand this power magnitude and all that we'll try to see. You know, this village people, they used to know this another data what is called as power in terms of horsepower. They used to have their pump set in terms of horsepower. So typically about 2-3 horsepower motor set they will be having. So one horsepower is 746 watt. Sometimes even they say like 736 or 746, or sometimes the median of 740 watt. Okay, to compare or is to feel for this power value. the typical wind turbine rating is about 1 megawatt. So the people from Kanyakumari or Palani region, they can understand this wind turbine easily. Kanyakumari Kanyakumari region is full of wind turbines. Even now south of the Tamil Nadu is having a lot of wind turbine, not only south.
Aralvaimudi, sir.
Aralvaimudi is very famous, right? Where Kanyakumari people are blessed with this another activity. There is a huge extraction of wind power, and for the entire India, the Tamil Nadu is a leader, and for the Tamil Nadu again, Kanyakumari region is a leading in terms of wind power generation. And another region is our Kovilpatti region, or this Kayathar region also having a lot of wind turbines. Even Kadambur region also I can see this wind turbine. The single wind turbine, or this huge turbine, is having a rating of about 1 megawatt. With 1 megawatt, we can supply to some 10,000 families. 1 megawatt is okay. How much? 1 into 10 power 6 watt. Normally about even people are consuming after about 1 kilowatt. Or for 1,000 family, a single wind turbine can support. Even our campus is also having a green energy harvesting in the form of solar energy. Solar energy panel in this electrical block and chemical engineering block.
Yes, sir.
Yeah, right.
Yes, sir.
Happy to know that. Thank you, ma'am. See, this solar is capable of meeting our entire campus power requirement. They are having a capacity of about more than 1 megawatt now. Without any electrical supply, we can run our campus, or we can sustain our campus without any power supply. So these are all to be understand that way. This idea of saying this, relating this is how to understand this figure in a understandable way, or how to keep these figures in a understandable way. Related with that is 1 ton of refrigeration. So this ton of refrigeration is a rating for these air conditioner units or refrigeration units. Why it is called as ton of refrigeration? In that kind of thing, I asked you to read about this ice house. Of course, ice house also I came to know about you people itself. Okay, ice house is for storing the in the British period they stored the ice. It was actually obtained from this, or shipped from America. Of course, we also have ice in these Himalayan regions, but we cannot easily transport that to the southern India comfortably in the period of 150 years ago. Whereas it was easily shipped from this America to India or to various parts of the world by this transporting in the ship. But normally it takes about some 2-3 months. By the time it is reaching the destination, half of the ice would have melted. Still, they could earn a lot from this by selling this ice. So the usage of ice is for refrigerating or for producing chillness. So otherwise, even 20 years back also, I can easily say that the people who are having this refrigerator were considered to be very rich people. Only the rich people can afford this refrigerator. Now this refrigerator is very common in every house. Even every house is having at least 2-3 air conditioners. Whereas these are all considered to be extra requirement. Or 10 years back also it was considered to be the Adambra Selavu nachanga, yeah. Now it is considered to be part of life, but still many people are also not using AC or refrigerator. I should appreciate that people. Any of you are not having AC in your house? They are doing a lot to the nation in the form of preserving. Dharmesh.
Yes, sir.
You don't have air conditioner there?
Yes, sir. No, sir. I don't.
Okay, great. Dharmesh, you are from Jhansi, no?
Yes, sir.
Happy to know that. Happy. Continue that. At least as long as you can continue, it will be better. Fine. Coming back, how this 1 ton of, why to have this ton of refrigeration? What is the significance of ton of refrigeration? We'll try to understand this figure. Yeah, before going to the pressure, of course, pressure will come to this later. Ton of refrigeration, it is this ton of refrigeration, nothing but if you allow this 1 ton of ice to melt in a period of 24 hours. So you'll be getting a cooling rate. Now, the 1 ton of ice multiplied by its latent heat of melting. That is the energy by time. If you melt, if you can melt 1 ton of ice in a period of 24 hours, so how much is the energy removal rate? That is equal to tons per say 24 hours. So otherwise you can say in terms of so much of kilocalorie per minute. So 1 ton of refrigeration is coming to be an approximate figure of about 50 kilocalorie per minute. So otherwise your 1 ton AC is removing heat after about 50 kilocalorie per minute. So this you can of course I'll show you the calculation here. Let me see, for example, it's a rate of cooling produced by melting of 1 short ton. Actually, these British people and US, UK, US people still use the another terminology, what is called a short ton, long ton. So this short ton is not actually equal to 1000 kg. 1 ton is actually 1000 kg metric ton, whereas if you convert that in terms of pound, it will be somewhere around some 2200 and 2200 pound. Instead, this British and Americans still they are very convenient in terms of short ton. So 1 short ton is actually 2000 pound. So if you melt 1 short ton of ice in a period of 24 hours, so the rate of cooling produced is equal to 1 ton of refrigeration. So this 1 ton is actually 907 kg of ice getting melted in a period of 24 hours. Okay, this is 907. So actually 1 ton is not simply equal to 1000 kg. So 1 ton, they are referring to 1 short ton of ice getting melted in a period of 24 hours. So if you always 1 short ton, say 907 multiplied by the kilo latent heat of melting, which is 80 kilocalorie per kg. So if you multiply that and divide by the time of about 24 hours, 24 into 60 minutes, so you'll be getting an approximate figure of about 50 kilocalorie per minute. Let's check that, no? So that you will be 1 minute. I can use Excel, no? The Excel is very comfortable, nice tool for any calculations. So we have 2000 pounds multiplied by 0.454 kg. So that is converted into kg multiplied by 80 kilocalorie per kg divided by a time of 24 hours into 60 minutes per hour. So which is giving a figure of 50.44 or roughly about 50. What is the unit? This is kilocalorie per minute. Okay, so our 1 ton of refrigeration is equal to 50 kilocalorie per minute. So whenever you see they are come to know about this air conditioner capacity, you should be in a position to convert in terms of kilocalorie per minute, or you can also express this in terms of power rating. How do you convert this kilocalorie per minute to power? Can any of you arrive at this figure? Kilocalorie per minute in terms of some nice data in terms of kilowatt. கொஞ்சம் போட்டு சொல்லுங்க பார்க்கலாம். One of you, some of you can arrive this. I'll take some water. Work out பண்ணிக்கலாமா? How much this 1 ton of refrigeration in terms of kilowatt? Kilowatt of heat removal. Kilojoules per second. Of course, I can convert this. We have, say, take this as 50 itself. 50
3.517.
Super, Yukesh, great. Happy to know this. Roughly about 3.5 kilowatt. Sorry, kilowatt. Yeah, correct. Kilowatt. So 3.5 kilowatt of heat is removed. 3.5 kilojoules of heat per second is removed. Okay. Thanks for Yukesh. Happy to know this. Okay. These are all to be noted. Okay. I'll have this audio recording. No problem. I can use it later. So air conditioner பத்தி இனிமே யாராவது சொன்னாங்கன்னா this 1 ton AC 2 ton AC na you should be in a position to understand the heat removal. It is not the weight of the air conditioner or the amount of air removed. Okay, these are all the figures normally people used to say. 1 ton AC na they used to say like 1 ton of air is removed. Or is 1 ton is not in terms of mass of the air. Or is it is the amount of ice getting melted. Of course, not we don't do ice melting of ice. Instead, we are producing the cooling as equivalent to that of the melting of ice. You know how this refrigeration is affected in our air conditioner or in our refrigerator? So people used to say some sort of fluid is circulating, How this refrigeration is affected in our air conditioner? Any of you know this? Refrigerator there are some parts, actually refrigerator is a nice unit to understand. It's a steady flow unit, there is something entering and leaving. So there is heat is taken and heat is rejected out. Do you know the components of our refrigerator or air conditioner? Achudan, Harish, they are trying.
Sir, compressor.
Good, compressor.
Coolant.
Nice. Coolant is there in circulation. Fine. Then compressor is the major unit. Otherwise, this we need to take the heat and reject to the surroundings. So there is heat at low temperature is taken. There is the refrigerated space is at a lower temperature of about 5 degrees Celsius or even up to minus 5 degrees Celsius. At that temperature, we are taking the energy from the objects and it has to be rejected out to the ambient. So for that, there is a refrigerant in circulation. So what is the refrigerant they used to have in this refrigerator or in air conditioner? What is the refrigerant used?
Sir, freons.
Freon,
CFC.
nice. Yeah, it is called as chlorofluorocarbons, CFC. Nice one. But they used to say about some impact on the environment. No, what is the impact of this CFC on the environment?
Greenhouse.
It destroys ozone layer.
Great. Many are responding. Thanks, ma. Ozone layer first. Nice reason is ozone layer. Of course, it is also having global warming potential or greenhouse effect. The major thing is ozone layer depletion. Of course, people could identify this as early as 1980s itself. They identified. Even they try to they taken up a lot of measures in the form of phasing out these CFC chemicals and replacing this CFC with a the alternate chemicals, what is called as hydrochlorofluorocarbons, HCFC, or even going back to the older refrigerants, what is called as SO2 or ammonia. This SO2 and ammonia are having good refrigerating effect. Or if you allow this liquid SO2 or liquid ammonia to vaporize, they vaporize at a lower temperature. At normal pressure conditions, they vaporize at a much lower temperature because of the low boiling point of the components. So otherwise, they are taking the heat from the exchanger, heat exchanger, and rejecting it to the atmosphere. So to the atmosphere, how the heat is rejected, or it is passing through these condenser coils. In the case of your household air conditioner, you would have seen this outdoor unit. Or even your air conditioner refrigerator is also having this coils on the backside of the refrigerator, which are all actually very hotter. In that, this refrigerant is circulating. How this temperature of the refrigerant is raised? So the refrigerant is vaporizing at a temperature of about minus 5 degrees Celsius and passing through the freezer compartment. It is taking up the heat. Still, it is at a temperature of say minus 5 degrees Celsius. And why they are converting this to a hot condition? This question is, so the refrigerant is capable of vaporizing at minus 5 degrees Celsius and it is turning from liquid to vapor. Still, now we are compressing this refrigerant and asking it to raising the pressure temperature of the refrigerant to after of about 45 or 50 degrees Celsius. Why do we raise the temperature to that high level? Why don't we keep this refrigerant at say minus 5 degrees Celsius itself?
Sir, so it cools faster, sir.
Yeah. Otherwise, only if it is converted to high temperature, then only can condense. Otherwise, we are condensing this refrigerant at a high temperature. To condense it at high temperature, we are actually supposed to raise the pressure. To raise the pressure, we have the compressor. Since it is at a high pressure vapor, this high pressure vapor is capable of condensing at high temperature after about it is condensing at 40 degrees Celsius itself. So 40 degrees Celsius it is condensing and it is vaporizing at a temperature of about minus 5 degrees Celsius. Otherwise, it is having a pressure difference only. Low pressure, low temperature, and high pressure, high temperature. So this is the relation between vapor pressure and boiling point. Okay, this and all we'll discuss. Otherwise, it is vaporizing at low temperature and rejecting the heat at high temperature. So to make this pressure difference, we have the compressor to affect this pressure difference. Of course, how to reduce the pressure? The reduction of pressure is much easier. It can be simply the fluid can be passed through a capillary device or some pressure reduction device. But to raise the pressure, we need to work a lot. So for that, there is a compressor. So the compressor is a power consuming device. The other things are simply heat transfer devices, taking the heat and rejecting. There is only the supply, energy supply is in the form of electrical energy. Okay, all this in terms of our refrigeration. Okay, now let us go to the other topic, which is pressure. How much time left? Another about 15 minutes left. It is in today's class we should finish this unit conversion. The pressure, of course, Pascal, which is Newton per meter square, and 1 atmosphere is having a pressure of 1.01325 into 10 power 5 Newton per meter square. How this 1.01325 is coming, that we can get to know in the topic of fluid mechanics. Okay, which is coming. This pressure we can also say in terms of column of fluid. Otherwise, in this hydrostatic head of the fluid is also creating a pressure. Otherwise, if you keep a column of 1 meter of or 10 meter of water column, you will see that 10 meter of, below the 10 meter water column, you will see experience a pressure of 1 atmosphere. Otherwise, if you go down water to a depth of about 10 meter, you will experience a pressure of 1 atmosphere over and above the atmospheric pressure. So 10 meter is you will be experiencing how much pressure in terms of absolute pressure? It is 2 atmosphere pressure you are actually experiencing. If you go down to a depth of about 10 meter in the water. In the கிணத்துல போனீங்கன்னா தெரியும் 10 meter column 10 meters about 30 feet 30 feet depth நீங்க கீழே போனீங்கன்னா காதுக்குள்ள கடையை தண்ணி போயிடும். Because the external pressure is acting and any hole is available, water will enter. Of course, it will create some problem as well. Even no need to go to that depth. Even if you go down to a depth of about 3-4 feet, also you will experience the water to enter your ears. Even you will experience this kind of pressure effects if you climb these mountains or if you travel this vehicle and reach this Ooty Kodaikanal, you will see that the kaadu adigira mari paathirupinga, your ear you will be getting some difference. So these are all because of the surrounding pressure, air pressure. So this air column, atmospheric air is having a height of air is available to a height of about 10 kilometers. So this 10 kilometer of air is acting upon the earth surface. So this earth surface, because of this 10 kilometer of air, we are experiencing a pressure of 1 atmosphere. Or this 1.01325 into 10 power 5 Newton per meter square at the earth's surface. So otherwise, if you go to a height of about 8 kilometer to which is the height of this Everest, you will see a very low pressure after only about 0.2 atmosphere pressure, which is not sufficient to meet your oxygen requirements. That's why people are carrying oxygen if you are making any high altitude trek. But people can comfortably trek to a height of about this 4.5 kilometers. Anything beyond that is considered to be risky. Of course, up to 5 kilometers also you can make. I could make of course, I made it some two treks after about 4.5 kilometers. Once in 2015, another in 2017 also. In 2017, even I could take my younger boy to this trekking. Any of you are interested, you can also think about it. Of course, I'm also supposed to start for a trek today. I registered for this trek, what is called as Burankati Pass trek. It's supposed to start today. There is supposed to start to Delhi today, and so the trek is supposed to start on this May 15th to 22nd in Burankati. In I'll even tell you this area. No, where is this pass? No, these are all something to explore. These areas are nice. Any of you are interested, of course, you can join with me late sometimes. This trek, we thought of joining with this even, of course, the other group, what is called as Bikat Adventures. Yeah, right. These are all the regions in the Himachal, in the Himalayas. you will actually start the trek from somewhere at a height of about 2,500 meters, and in a period of about 4-5 days, you will reach a stretch of you will reach to the height of about 4.5 kilometers. And again, you will make a descent within about 1 or 2 days and reach the base. About 7-8 days, you have to make a comfortable walk in this Himalaya regions. So these are all the nice area to explore. This and all you can try yourself. Okay, coming back. So idea of saying this pressure is of even now also people are feeling about this pressure, and because they are this corona, COVID, they are feeling about this uh, inadequate supply of oxygen. Okay, this and all we'll discuss in the coming class. Now next, okay, this horsepower is about actually the one horse is lifting a weight of about 550 pound and making a lift of about 1 feet in a time of that in the time duration of 1 second. So the power is actually this mass mg h what is it m, and g is actually acceleration due to gravity. If you multiply this 550 multiply by 9.812 and a height of 1 feet divide by the time of 1 second, you will be arriving at this figure of the 746 watt. Okay. The idea of using this watt horsepower is because in the olden days only the horse were used to for any transportation or for any movement. Even still village people are using this what is it bullocks, no? Even I can also say like 30 years back I used to go along with my grandfather to in this agricultural field to hold this the kalapayam pidichittu even nanu ulavula adichirukken. Even the grandfather, even along with my father till my college, no? After then we even sold out our agricultural land and moved to city. Now every people those who could study, they are moving out of the city, moving out of the village, and they are also forgetting the agriculture. Okay, not to worry much, and there are we could improve our productivity of agricultural land, so that way we are meeting our requirements. Now coming back, okay, coming to the other things aspects. So this we know we used to say about this data in terms of the prefixes like pico, nano, micro, milli, kilo. Kilo, mega we are in a position to understand. Even giga also we are comfortable because of gigabyte of storage or gigabytes of your data transfer. And next thing is terabyte is because of the our even the hard disks are now thought of terabytes, whereas 20 years 25 years back they were only about kilobytes. 240 kilobyte ஒரு பெரிய டிஸ்க் இருக்கும், பெரிய டிஸ்க். ஈவன் that you cannot now use even the computer size டிஸ்க்ல இருந்தது பெரிய size. Later it reduced to 1.44 MB, or is the size reduced and capacity increased, and now we don't have that floppy disk, and we are having pen drive in the form of gigabytes. So the giga is 10 power 9 and mega tera is 10 power 12, and adukku mela enna irukku peta is there. Okay, peta and exa, lot of other figures are available. And less than this kilo is we have centi is actually 10 power minus 2, and milli is 10 power minus 3, and micrometer is very common in physics units. And nano, people are working in nano now, 10 power minus 9. Even nano, pico, even femto, there are a lot of other thing available. Okay, maybe I will ask this thing. 1 ton of refrigeration is equal to 50 calorie per minute. இது முடிஞ்சா நீங்க prove பண்ணுங்க. And I will ask you to work out the land availability per person. Okay, in terms of agricultural land. No, of course land is available. Some lands are forest land, or some are barren lands which we don't have access. So how much is the agricultural land available? You try this figure and let me know in the tomorrow's class. And another related thing is about this in addition to food, we also okay, food is for our this meeting our energy requirement, basic energy requirements. For our comfort, we are using these petroleum fuels. That is for our mobility, and for our electricity we are using this petroleum fuels. People used to say this petroleum fuel prices in terms of barrel. What is the one cost of 1 barrel of crude oil? Any of you know this data? 1 barrel of crude oil. மக்கள் எல்லாம் இருக்கீங்களாப்பா, லைன்ல இருக்கீங்களா? ஓகே. 1 barrel refers to தமிழ்ல சொல்லுவாங்க. தமிழ்ல சொல்லணும்னா barrel is actually in Tamil newspaper, if you read barrel, they used to say this in terms of பீப்பாய். கேள்விப்பட்டீங்களாப்பா பீப்பாய்? Of course பீப்பாய்ங்கிறது நம்ம தமிழ்ல அதாவது people used to say this பீப்பாய்ங்கிற word they used to say for those who are very bulky. பெரிய பீப்பாய் அப்படின்னு ஒரு வேர்ட்ஸ் யூஸ் பண்ணுவாங்க இந்த குண்டா இருக்கிற பசங்களுக்கு. பீப்பாய் is the size of 1 barrel. 1 barrel is 159 liters. So 159 liter is of course 159 kg roughly. So 150 கிலோ இருக்கிறால பீப்பாய்ன்னு சொல்றது தப்பு இல்லை இல்லையா? Because they are weighing the size, roughly the same size. So barrel and பீப்பாய். இந்த பேரல் இங்க கூட பார்த்துருப்போம் நம்ம. ஈவன் this இது இருக்குல்ல கெரசின் பேரல்லாம் கூட பார்த்துருப்பீங்க இல்லையா? That is also of the size 159 liters. So you try to work out in terms of kg, how much is a kg of how much is the weight of 1 barrel of oil. Okay, this three things you try and எப்படி அனுப்பலாம். You please write these contents in your note and simply take a scan of this and upload this in like LMS la I'll create an activity for this. You take this screenshot of this page and you have to write these contents in your pen and paper and simply take a screenshot and upload that as a PDF in the LMS. Okay, this is activity for the day. Okay, time, how much time left? Another about 3 minutes. Let us quickly summarize whatever we have seen in this last 2 classes. Of course, first class more of introduction, second and 3 were about these units. Mass, length, time. Not only SI units, we also have FPS system of units. And these things, the basic things we use in chemical engineering are this velocity or speed and force, pressure, energy, power. Okay, these are the more common most common dimensions. Okay, for that, okay, what is all things available? Meter, feet, then what else? Even mile also sometimes we used to use, but mile is not used in our calculation because mile is not we used to say in terms of either meter or feet. And area in terms of normally feet square or meter square, and not my area is not much used. We used to refer in terms of meter cube, or volume is very convenient for us because everything we are processing in terms of so much of fluid entering in a pipeline, which is having which is a three-dimensional unit. So length, volume, and temperature is very commonly used. You should know these conversions. And force also we don't use much because instead of force we used to use in terms of pressure. So force per unit area is the pressure. And next, energy and power. These are all very quite often used in chemical engineering. Okay, இதெல்லாம் relate பண்ணி these problems are available. These 3 questions you try to finish this activity before the coming class. So இது வரைக்கும் என்னென்ன activity இருக்கு? You have to finish your database entry, which is about your introduction, and the other thing is about voice file, which is about again self introduction. The third activity is about simply making a calculation, maybe not more than one page calculation, and simply write this in your own handwriting and take a scan of that and upload this in LMS. I will create a link and that link will be the top in the LMS. Okay, pass. See you all in the coming class. Any of you have any difficulty or any of you want to say something? I will be the last person to leave. Till the last, okay, I will be available. Okay, thank you all. See you in the next class. Please complete all these activities. Okay.
Thank you, sir.
Thank you, sir.
Thank you. See you all.
Thank you, sir.
Thank you. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, ma.
Thank you, sir.
Thank you all. See you all.
Thank you, sir.
Thank you.
Bye, sir.
Thank you. Thank you, pa. Okay, Michael, Sandhya, and Vaishnavi are still available. Close pannilamapa. I think since there is no response, I will close this.